Hey guys, so today we are going to be working on catching up problems. So for our first catching up problem that I'm going to go through with you, it tells us that Julie can run at a speed of 100 meters every minute. And it asks us, how far can she cover in 5 minutes then? So we know that in 1 minute, she can travel 100 meters. But it's asking us how far can she go in 5 minutes. So if we know that in 1 minute she can do 100 meters, and we're asking us how far can she go in 5 minutes, what we're going to do is we're going to multiply 100 by 5, right? Because for every minute you go 100 meters, so then by the time you reach 5 meters, you should have 500 meters. So that's our answer for example 1. Example 2 is similar. So they tell us that David's speed is 2 meters in 3 seconds. Now they're asking us, how long does it take David to go 50 meters if he swims at the same speed? So then what we're going to do is we're going to take our 50 meters and we're going to divide it by our 2 meters. And what we get is 25. And we're going to take our 25, and since we have our 3 seconds for our speed, right, we're going to multiply it by 3. So what we get is 75 seconds. It takes us 75 seconds to swim 50 meters going at the same speed. So that is the answer for example 2. Now this problem is a little different. So it tells us Danny can walk 80 meters per minute, so that's Danny's speed, and Melissa can walk at 55 meters per minute. They start walking towards school from the same place at the same time, and they ask us, how far is she from school, Melissa, when Danny is already at school 5 minutes later? So if it's easier, then what you can do is you draw it out, right? Danny and Melissa are at the same place. Danny is walking, Melissa is walking, but then Danny is here 5 minutes later at school, but where is Melissa? How far is she? What is this distance right here 5 minutes later when Danny has arrived? So what we're going to do, right, we know that they've been walking for 5 minutes. So what is 80 times 5, right? What I got the 80 from was Danny's speed. So I know my distance will be 80, Danny's speed, how long he was walking. Because if he walks 80 meters per minute, then in 5 minutes he will have walked 400 meters, right? Now we're going to look at how far Melissa has walked in the same time. So Melissa had a speed of 55 meters per minute, and she's also been walking for the same amount of time, 5 minutes. So we know Melissa has walked 275 meters, because what we did, right, if for every minute she walks 55 meters, then in 5 minutes, 55 times 5, she will have walked 275 meters. So that means that from where they were to school, it's 400 meters, right? Because we know that because Danny's already there and he's walked 400 meters, and Melissa has walked 275 meters. This is how much Melissa has walked. And they're asking us for this. So if this entire length is 400 meters and this entire length is 275 meters, what we're going to do is we're going to take 400 minus 275 to get this distance right here. So what we get, 135, 35, sorry. And that is how many meters we get, 125 meters. So Melissa is 125 meters away from school when Danny arrives 5 minutes later. And now for our final problem. It tells us a car travels from town A to town B at a speed of 80 kilometers per hour. 2 hours later, another car travels in the same direction at 120 kilometers per hour. When can the second car catch up with the first one? So there's 2 methods that we can do this. We're going to do, right, we can make a table. So in the first hour, we know that the first car is 80 kilometers per hour. So in the first hour, it'll have traveled 80 kilometers. In the second, another 80, so 160, and then another 80, 240, and then another 80, another 80, another 80, so 320, 400, 480. Now, 2 hours later, another car travels in the same direction. So that means that for the first hour, it wasn't driving yet, right? So it hasn't covered any distance. For the second hour, it hasn't either because it didn't start driving until 2 hours later. And it says 120 kilometers per hour. So then we start off with 120. Another hour, it has traveled another 120. So that means that we'll have 240 for the next hour. And then another 120. And then another 120. So if we look at our table, we see that the distance traveled by both of them, whenever they are the same, is when they have caught up. And in the 6th hour, we know that they have caught up. So in the 6th hour is when they have caught up, but it's asking when can it catch up with the first car. But we know that the second car only started driving in the 2nd hour. So that means that after the 6th hour, minus these 2 hours, it'll have, not 2 hours, sorry. Yes, 2 hours. After the second, then it'll have caught up with the other car in 4 hours. For our second method, what you could have done is you could have multiplied 80 by 2, and you would have gotten 160. And then you would have looked at your speed for the second one. You could have done 160 divided by our 40, and then we would have gotten 4. So then that is when, after our 4 hours, we could have caught up with the first car. And that is the final problem for catching up.